Hello, a very good evening to all, and welcome to the class. Today is the sixth or seventh class of the हाइड्रोकार्बन्स. ठीक है. सो ओके 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 ठीक है. गुड इवनिंग, गुड इवनिंग. So today we are going to start alkyne series. Okay, we already cover alkane and alkene. So in today class we are going to start a alkyne series. This is going to be a very important class for all of you, in which we learn the method of preparation of alkyne, their chemical properties, their physical properties, and various acidic natures. Right. So it's going to be a very interesting session for all of you. तो चलो start करते हैं. The first one is preparation of alkyne. Before starting with this, let me confirm my voice is audible to all of you, right? And my screen is also visible. Done everything? Done it? Okay. Now, so preparation of alkynes. Okay, so let's see how will you prepare alkyne. So the first method for the preparation of alkyne is from calcium carbide, right? So from calcium carbide, we prepare alkyne. How will you prepare? Let's see. So this is the industrial method for the preparation of ethine. Remember this thing. This is the industrial method for preparation of ethine and production of quicklime by heating limestone. Okay. So remember this thing. First of all हम क्या करते हैं कैल्शियम बनाएंगे कैल्शियम कार्बाइड से ही. लेकिन ध्यान से देखो पहले हम लोग क्या प्रिपेयर कर रहे हैं. ठीक है. बिकॉज दिस इज अ इंडस्ट्रियल मेथड फॉर द प्रिपरेशन ऑफ इथाइन. तो सबसे पहले तो हम क्विक लाइम बनाते हैं. क्या बनाते हैं? Quicklime. How will you produce quicklime? By just thermal decomposition of calcium carbonate. तो जैसे ही calcium carbonate को decompose करते हैं तो we got CaO plus CO2. This CaO is known as quicklime. Now, the carbon carbide are produced by heating quicklime with coke. तो जैसे ही कार्बन के साथ क्विकलाइम को हीट करते हैं, राइट, सो हम लोगों को क्या मिलता है? कैल्शियम कार्बाइड. सो हेयर वी हैव अ क्विकलाइम कैल्शियम ऑक्साइड, एंड व्हेन वी ट्रीट दिस कैल्शियम ऑक्साइड विद कार्बन, देन वी प्रोड्यूस calcium carbide, right? So this is how we'll prepare calcium carbide. Is this clear to everyone? How will you prepare calcium carbide in industries? Because calcium carbide is needed for the preparation of ethine here, right? So I'll explain just कि how to prepare this calcium carbide. ठीक है, तो यही मैंने आपको just अभी explain किया. Okay, let's see. What is the structure of calcium carbide? So calcium, we all know that calcium is a metal belong to group 2. So having +2 charge, it definitely in C2 molecule, we have a -2 charge. So this is the structure of carbide ion, right? So this is the structure of carbide ion. Now, the production of ethine by treating calcium carbide with water. Let's see how they prepare. So we have a carbide ion, that is C triple bond C negative, and when we treat this with H2O, then calcium hydroxide and ethine is produces, right? So this is how will you prepare ethine from calcium carbide. I hope this is clear to everyone. समझ आया? Done? Good. Chalo, next. Let's see the next one. The next one is the next method we say. Okay, from vicinal dihalide. Okay, so we all know now what is vicinal dihalide. Can anyone explain me? What do you mean by this term vicinal dihalide? Anyone? What do you mean by this term vicinal dihalide? We already studied this thing in preparation of alkene as well. Okay, so vicinal dihalide means when the two halogen atom are attached adjacent to the carbon atom. यानी जब दोनों adjacent carbon पे एक एक halogen atom लगा होता है, then we call this is a vicinal dihalide. So when we treat this vicinal dihalide, halides on consecutive carbon. Good, Harmit. Good. So when we treat the vicinal dihalide in presence of alcoholic KOH and NaNH2, right? Remember this thing. When you treat vicinal dihalide in presence of alcoholic KOH and NaNH2, then alkyl will took place. Okay. So let's see the mechanism behind this reaction, how this reaction proceeds. So we have a vicinal dihalide, right? We have a vicinal dihalide. And when we treat this vicinal dihalide with KOH, so we all know that K having positive charge, OH having negative. So here OH act as a nucleophile. So OH act as a nucleophile. तो ये OH easily इस H को अपने पास ले लेगा और फिर यहाँ पे ये कार्बन कार्बन डबल बॉन्ड बनेगा और यहाँ से X का रिमूव होगा यानी एक तो यहाँ पे KX निकला एंड अनदर इज H2O that is KX and H2O दोनों रिमूव हुआ then formation of alkene will takes place right now when this alkene is treated with again NaNH2 right here NH2 act as a nucleophile then again NH3 and NaX will be removed and formation of alkyne will took place ठीक है तो यहाँ पे क्या मिल गया हम लोगों को alkyne का formation होता हुआ मिला for example let us consider an example to understand in a better way for example if we have 1,2-dibromoethane right what we have 1,2-dibromoethane when we treat this 1,2-dibromoethane with KOH and NaNH2 right when we treat this 1,2-dibromoethane with KOH and NaNH2 then ethyne will be produced, right? So in the first step, OH act as a nucleophile. In the second step, NH2 act as a nucleophile, right? So we can say that when 1,2-dibromoethane is treated with KOH and NH2, then formation of ethyne will take place. So this is just the two method you need to remember in case of alkyne method of preparation. The one from that is from carbon carbide and the other is from vicinal dihalide. So these two are the most important method for the preparation of alkyne. Okay. So I hope this is clear to everyone. Yes. Anyone having any kind of doubt you can ask. Otherwise we move to the next property that is called physical properties. Anyone? Any kind of doubt in this two method of preparation? Yes? No? Shall I proceed? Okay. Chalo. Yes, sir. Okay, beta. Chalo. Move. Now, what are the physical properties of alkynes, right? So let's see some physical properties of alkyne, just as we see in case of alkane and alkene, it is similar to this, right? So at room temperature 298 Kelvin, we can say that C2 to C4 are gaseous, right? C2 to C4 are gaseous because for alkyne, minimum number of carbon must be 2, right? Then only alkyne exists. So C2 to C4 is gas, C5 to C12 is liquid, and above C13 they all are called solids. Okay. Now all alkynes are colorless यानी जितने भी alkynes होते हैं वो colorless होते हैं. All alkynes are odorless except ethyne. So all alkynes are colorless, all alkynes are odorless, and they are insoluble in water as well, right? So remember this thing, just like an alkene they are also insoluble in water. Now they are fairly soluble in non-polar solvent like benzene, ethers, and carbon tetrachloride. If we talk about the melting and boiling point and density, all increase with increase in the molar mass, just as we see in the case of alkane. Ki as the carbon content increase, molecular mass increases, van der Waals force increases, or we can say that their melting and boiling point also increases. So it remains same for alkyne as well. Now, uh, okay. Can anyone tell me the answer? Compare the boiling point of ethyne, propyne, and but1-ine. Which will show higher boiling point? Ethyne, propyne, or but1-ine? First, yes. which will show ethine, propine, and butane. Okay, so in ethine we have two carbon, propine we have three carbon, and butane we have four carbon. So they are asking out of these which will show maximum boiling point. So it's a very simple question, right? So we know that boiling point increase with increase in the molecular mass. It means as the number of carbon content increase, boiling point also increase. So we can say that butane. बिल्कुल हर मित्र सही बोला है. Good. So butane show higher boiling point. Good. Now, this is very, very, very interesting topic in this chapter, that is acidic character of alkynes. Alkynes are very good acidic in nature, right? So let's see how they behave as a good acid. Okay, so the acidic character of alkyne. So let's give some evidence so that actually you understand why alkyne are said to be good acidic, right? So let's see. So first of all, whenever we treat ethine with some active metal like sodium, right? So they liberate H2 gas, and we know that the substance which will treated with the metal, or we say reactive metal, and when they liberate hydrogen gas, it must be an acid, right? आपने देखा होगा इन योर प्रीवियस क्लासेस ऑल्सो कि अगर मैं H2SO4 वगैरह को ट्रीट करता था मेटल के साथ, तो वहां पे हाइड्रोजन गैस निकल रहा था. इसका मतलब एसिड है. यानी वेन एवर एसिड रिएक्ट विद इन अ मेटल, लिबरेशन ऑफ हाइड्रोजन गैस विल टुक प्लेस, right? So similarly, when we treat some metal with alkyne, hydrogen gas is liberated. So this include मतलब this confirm that the ethyne are acidic in nature. कि ethyne क्या होता है? एसिडिक नेचर का होता है. डन. ओके, लेट्स सी थ्रू एन एग्जांपल. इफ वी हैव इथाइन, that is CH triple bond CH, when we treat this ethine with sodium, then acetylide ion plus Na plus half H2 gas will liberated out. Now alkyne also react with soda amide, that is NaNH2, which is a strong base. Okay, so it's also give evidence that this is acidic in nature. So whenever ethine is treated with NaNH2, monosodium ethynite plus ammonia is formed. Now, the question arises, why ethine are acidic? It is proof that कि जो इथाइन होगा वो एसिडिक होगा. Now the question is why acidic character of alkyne, why they are acid. Okay, so let's understand why they are called acidic. So explanation for the acidic nature. So suppose we have an alkyne group. Now we all know this carbon having sp hybridized, right? How we see sp hybridization? Because hybridization depend upon number of sigma bond plus lone pair. Now, here how many sigma bond we have? One sigma bond and two sigma bond only. Because in triple bond, we have two pi bonds and one sigma bonds, right? Two pi bonds and one sigma bond. So we can say that here only one sigma bond is present between carbon-carbon and one sigma bond with the hydrogen. So we can say that they were having 2 plus 0, that is 2. 2 means क्या हुआ? sp. So carbon here in case of ethyne are sp hybridized carbon. Now, in sp hybridized carbon, we all know that sp hybridized carbon possess 50% s character, right? sp hybridized s character होता है, that is 50%. So 50% is s character and 50% p character. Now, कार्बन विच इज अ मोर इलेक्ट्रोनेगेटिव कार्बन एटम, यहाँ पे जो कार्बन एटम है वो ज्यादा इलेक्ट्रोनेगेटिव कार्बन एटम है. क्यों? बिकॉज जितना ज्यादा इलेक्ट्रोनेगेटिव कार्बन एटम होता है उतना अच्छा एसिडिक कैरेक्टर भी होगा. तो हम सबको पता है आउट ऑफ sp, sp2 एंड sp3, sp इज मच मोर एसिडिक इन नेचर. और हमें ये भी पता है क्यों? बिकॉज अगर किसी का एस कैरेक्टर ज्यादा है, इट मींस वो एटम जो है वो ज्यादा इलेक्ट्रोनेगेटिव है ऑब्वियसली. सो ड्यू टू sp हाइब्रिडाइज कार्बन, they are more electronegative, or if they are more electronegative, it means more acidic strength, because acidic strength is directly proportional to ease of donating H plus ion. तो अगर ये ज्यादा इलेक्ट्रोनेगेटिव होगा तो ये इसके इलेक्ट्रॉन को इजिली ले लेगा। और यहाँ पे H प्लस बन के ये निकल जाएगा। एंड व्हाट इज एसिड? जो भी H प्लस लूज करता है, whenever the substance or compound, if they loses H plus, then they are said to be good acidic character. So similar in case of ethyne, because in ethyne carbon having S character 50%. Due to this they are much more electronegative, and due to more electronegativity they tends to shift the electron towards itself, and H plus easily releases, right? So we can say that acidic strength is directly proportional to ease of donating H plus ion. H plus ion पे डिपेंड करता है। नाउ देखो ध्यान से, all hydrogen in alkynes are not acidic in nature. Only those which are attached with triply bonded carbon atom are acidic. Okay, so जितने भी हाइड्रोजन होते हैं, all hydrogen, so all hydrogen in alkynes are not acidic in nature. Only those which are attached with the triply bonded carbon atom are acidic. So this point you must remember कि सारे के सारे हाइड्रोजन एसिडिक नहीं होते हैं। सिर्फ वही हाइड्रोजन जो ट्रिपली बॉन्डेड से अटैच्ड होते हैं, दे आर मच मोर acidic. Okay, now let's see through an example. So in case of ethyne, these H are acidic hydrogen, right? So they form monosodium ethanide और H2 गैस निकल गया। Again they form disodium ethanide और H2 गैस निकल जाएगा। For example, in propine also this carbon is acidic in nature, तो ये acidic hydrogen हो जाएगा, right? Further ये react करेगा? No, because this one is not the acidic hydrogen, ये तो दूसरे कार्बन से attached, तो ये एसिडिक हाइड्रोजन नहीं होगा। डन? इज दिस क्लियर? चलो भाई, नेक्स्ट देखो, नेक्स्ट देखते हैं। नेक्स्ट व्हाट वी हैव, क्लियर? Okay. So how will you prepare pent one ine using ethyne? Okay. So next we'll have how will you prepare pent one ine using ethyne? So ethyne से pentine पे जाना हो. So we take ethyne with one equivalent of Na, and when we treat sodium ethynate at propyl halide, right? Then substitution reaction will take place and you'll get the product. So this is an important method to prepare higher alkynes from ethyne. So whenever you want to prepare higher alkynes like pentyne, hexyne, heptyne, so you can use this method. Okay. Chalo. Now, the question is how would you differentiate between but 1-ene and but 2-ene? So we can say now in but 1-ene acidic hydrogen is present, but but 2-ene acidic hydrogen doesn't exist, right? So in this we have an acidic hydrogen, in this we do not have any acidic hydrogen. Now let's see chemical properties of alkynes, ठीक है? तो अब हम लोग chemical properties of alkynes को cover करने वाले हैं. So let's see. So if we talk about the chemical properties of alkyne, they show addition reaction, right? So alkyne show addition reaction. Okay. So which type of addition reaction? So they show electrophilic addition reaction. How? Because in alkyne we have a triple bond, right? 5 bonds are there. So they behave as the electron rich compounds. So electrophile on this rich compound. Okay, so that's the reason they show electrophilic addition reaction. Okay, now second, they also follow Markovnikov's rule, right? So they follow Markovnikov's rule. So first case में क्या होता है? If we try to understand the mechanism behind this, so in the first step we have electrophile attack to this alkyne, right? So this will formation of vinylic cation will took place. Now the nucleophile part come and attack to this carbon atom. So the reaction took place, right? Where E is a electrophile and Z negative act as a nucleophile. Okay. Now let's see the addition of hydrogen first. So if we have alkyne and we add H2, that is hydrogenation, in presence of platinum, palladium and nickel, then the formation of alkene will took place, right? क्या बना? alkene. And again, if we treat this alkene with H2, again in presence of PT, PD, and Ni, then formation of alkene will took place. Just as an example, if we have ethine, when we treat ethine with the 2 mole of hydrogen, then formation of ethane will took place. Done? Now, let's see the addition of halogen. Just their reactions are almost similar to the alkenes, right? So their reactions are quite similar to those of alkene. Now, if we treat alkyne with halogen, X means what, beta? Halogen. So when we treat this alkyne with halogen, then dihaloalkene will form. Again, when we treat with plus X2, that is plus Cl or Br or I anything, then formation of tetrahaloalkane will took place, right? Let's understand with an example. Suppose we have a propine, right? If we have a propine, so when we treat this propine with 2 mole of Br2, then 1122 tetra bromo propane will formed. क्या बना? 1122 tetra bromo propane. So 1122 tetra bromo propane का फॉर्मेशन यहाँ पे देखने को मिलता है. Is this clear to everyone? Done? Now, this reaction is very important. इसमें मार्कोनिक्स रूल को भी फॉलो करेंगे हम लोग. So addition of hydrogen halide. So let's see how this reaction of ethyne with the hydrogen halide will took place. So if we have an alkyne and when we add hydrogen halide to it, then haloalkene will form. Again, when we treat with HX, then dihaloalkanes or we say jam dihalide will form. Let's understand with an example. Suppose if we have ethyne, that is CH triple bond CH, and when we treat this ethyne with HBr, right? So when we treat this ethyne with HBr, then bromoethane will formed. क्या बना? Bromoethane will formed. Now again, when we treat this bromoethane with again 1 mole of HBr, then 1 comma 1 dibromoethane will formed. What they form? 1 comma 1 dibromoethane. Okay, so now it's your turn. Tell me the correct answer for this question. So in this question, they're asking find the compound A and B. So you need to find A and B here, right? Here, peroxide is mentioned. Remember this thing better. So this is in case of HBr, right? This follows the Markovnikov's rule. Now this is HBr they are mentioning. HBr means anti-Markovnikov's rule. So just tell me the product. पहले प्रोडक्ट क्या बना होगा? फर्स्ट में फर्स्ट में कहीं भी मेंशन नहीं है मार्कोनिकॉफ रूल, बट इन सेकंड केस वहां पे मेंशन है. डाइब्रोमोब्यूट वन इन. हरमित, डाइब्रोमोब्यूट वन इन. अच्छा, वो डाइब्रोमो कहाँ कहाँ पे है? अच्छा, जस्ट ब्रोमो. ब्रोमो ब्यूट वन इन. ब्रोमो ब्यूट वन इन, ठीक है. ओके ओके ओके. चलो, एनीवन एल्स जो कोई बोलना चाहे? नो. देखो भाई, फर्स्ट ऑफ ऑल व्हेन वी ट्रीट दिस ब्यूटाइन विथ HBr, राइट? पहले तो हमने HBr के साथ ट्रीट किया तो Br लगा होगा, सेकंड कार्बन पे आके मार्कोनिकॉफ एडिशन हो गया है. नाउ व्हेन वी ट्रीट दिस विथ HBr, अब ये एंटी मार्कोनिकॉफ्स होगा, यानी ये आके लगेगा CH2 के पास Br, राइट? तो अब CH2 के पास Br लगा. हम्म. तो एक Br तो पहले से था, एक Br और लग गया. सो क्या बना प्रोडक्ट? दैट इज विसिनल डाई ब्रोमोप्रोपेन. विसिनल डाई ब्रोमोप्रोपेन. सो दिस इज द प्रोडक्ट बेटा, राइट? दैट इज 1 2, राइट? सो 1 2 डाई ब्रोमोप्रोपेन. सो ये होगा करेक्ट आंसर, राइट? वन ड्राई ब्रोमोब्यूटेन नहीं बेटा, 1,2, बिकॉज फर्स्ट वन इज अ मार्कोनिक ऑफ एडिशन, सेकेंड वन इज अ एंटी मार्कोनिक ऑफ। गॉट इट एवरीवन? कैसे हुआ ये? डन? एवरीवन डन विद दिस? चलो भाई, गुड। Now, let's see chemical properties of alkyne, next part. So, addition of water, right? So, this also follow the Markovnikov's rule. ठीक है, एडिशन ऑफ वाटर ये भी मार्कोनिकॉफ रूल को फॉलो करेगा। तो देखते हैं एडिशन ऑफ वाटर किस तरीके से हो रहा है, और क्या इंपॉर्टेंट इंपॉर्टेंट चीजें हमको इसमें याद रखनी है। सो सपोज इफ यू हैव एन अल्काइन, राइट, हमारे पास क्या है? अल्काइन। इफ वी हैव, सो दिस इज अल्काइन। When we treat this alkyne with H2O in presence of HgSO4 and H2SO4 at 333 Kelvin, then aldo or keto form will be formed. Obviously, एक OH लग जाएगा आपका. Now this OH is not stable, so यहाँ पे aldo और keto form का formation हो जाता है. So let's see the mechanism behind this. सो इन द फर्स्ट स्टेप, द इथाइन पे अटैक किया Hb+2 ने, राइट, एंड फॉर्मेशन ऑफ थ्री मेंबर साइक्लिक नॉन क्लासिकल कैटायन इज फॉर्म, राइट, थ्री मेंबर। नाउ अगेन H2O कम्स इनटू द पिक्चर, जहां पे H2O के पास लोन पेयर ऑफ इलेक्ट्रॉन है, तो वो H2O को इजिली रिलीज करने में हेल्प करेगा। देन, सो सॉरी, देन हम लोगों का ये फॉर्मेशन होगा अल्कोहल का, जो कि बिल्कुल भी स्टेबल नहीं होगा, पॉजिटिव चार्ज Hg+ पे। तो यहाँ पे H+ निकलेगा और इनोल फॉर्म का फॉर्मेशन हो गया। सो इनोल फॉर्म बना, फिर ये आपस में टॉटोमेरिज्म शो करेगा, और शो करके CH3CHO का फॉर्मेशन हो जाएगा। सो लेट्स अंडरस्टैंड विद एन एग्जांपल। तो सपोज यहाँ से आपको ज्यादा बेटर समझ आएगा। तो सपोज इफ वी हैव एन इथाइन, क्या है हमारे पास? इथाइन। तो suppose if we have an ethine, and when we treat this ethine with H2O in presence of Hg+2 and H plus, okay, then formation of ethanol will took place। क्या मिलेगा? इथेनॉल। तो इथेनॉल का यहाँ पे, सॉरी, इथेनॉल का यहाँ पे फॉर्मेशन हुआ, राइट। कैसे हुआ होगा देखो, ये है पार्शियल नेगेटिव, दिस इज पार्शियल पॉजिटिव, राइट। सो अब तो यहाँ तो कहीं भी ले जाओ, आप कोई प्रॉब्लम नहीं है। तो हम OH को ले गए यहाँ, बिकॉज इट सिमेट्रिकल एल्कीन है। H गया यहाँ, तो दिस विल बिकम CH2CHOH, दैट इज इथेनॉल। नाउ इस इथेनॉल का होगा टॉटोमेरिज्म, and this will get converted into CH3, CH3CHO, that is aldehyde. Okay, ethanol में convert हो गया। Now, suppose if we have a propine, अब बताओ भाई, again Markovnikov addition, negative, positive. Now ये negative कहाँ जाएगा? This negative goes to which carbon? So this negative goes to the carbon which contain the less number of हाइड्रोजन। तो कहाँ जाना चाहिए, जल्दी बोलो। ये है कार्बन कार्बन डबल बॉन्ड, इस कार्बन पे H लगा है, इस कार्बन पे CH3 लगा है, ऑब्वियसली। तो ये कहाँ चला गया, ये OH पार्ट? यस, किसने रिप्लाई किया? वन पे, गुड। सो ये OH पार्ट कहाँ गया बेटा? सो दिस इज CH3, ये OH निकल के आ गया यहाँ पे। ओके, सो OH एंड दिस विल बिकम CH2, अगेन टॉटोमेरिज्म होगा, एंड फॉर्मेशन ऑफ प्रोपेनोन विल टुक प्लेस। किसका फॉर्मेशन हो गया? प्रोपेनोन का। यानी इफ वी टुक इथाइन, अगर हम इथाइन लेते थे, देन क्या बन रहा था? इथेनल। अगर हम प्रोपाइन लेंगे, इफ वी कंसीडर प्रोपाइन, देन फॉर्मेशन ऑफ प्रोपेनोन विल टुक प्लेस। गॉट इट? Now, let's see the next one, that is polymerization reaction. Okay, what is this polymerization reaction? So, the first is linear polymerization. So, under the stable condition, linear polymerization of ethyne took place, right? So linear polymerization. So under a suitable condition, linear polymerization of ethine takes place to produce polyethine. क्या बनाएगा? Polyethine. तो polyethine का यहाँ पे formation होगा. Suppose if we have an ethine, n number of ethine if we have, हमारे पास मान लो बहुत सारे ethine है, n number of. Now, जब इसका हमने पॉलीमराइजेशन किया, राइट, व्हेन वी पॉलीमराइज दिस, देन पॉलीइथाइन विल फॉर्म, पॉलीथीन, ठीक है, पॉलीइथाइन विल फॉर्म. सो अंडर द स्पेशल कंडीशन, पॉलीइथाइन कंडक्ट इलेक्ट्रिसिटी and the thin film of polyacetylene can be used as an electrode in the battery as well. Okay, now this film are the good conductor, lighter and cheaper than the metal conductors. ठीक है, तो ये क्या होते हैं? सो दीज फिल्म आर गुड कंडक्टर, लाइटर एंड चीपर देन द मेटल कंडक्टर. दैट्स व्हाई वी आर यूजिंग दिस. ओके, सो दिस पॉलीथाइन और वी से पॉलीएसिटाइलिन आर वेरी यूजफुल फॉर अस, राइट. नाउ नेक्स्ट देखो, वो लीनियर पॉलीमराइजेशन था. दिस इज कॉल्ड साइक्लिक पॉलीमराइजेशन एंड दिस इज वेरी 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 इंपॉर्टेंट, राइट. मैं स्टार मार्क कर रहा हूं पेपर के पॉइंट ऑफ व्यू से. दिस इज very very much important reaction when we have a cyclic polymerization of 3 mole of ethine, right. कितना इथाइन लिया है? 3 mole. So if we consider the 3 mole of ethine in presence of red hot iron tube at 873 Kelvin, then formation of benzene will took place. क्या हो जाएगा? बेंजीन का फॉर्मेशन हो जाता है. So this is going to be a very 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 interesting reaction, that how will you prepare benzene from ethine. So whenever someone asks the preparation of benzene from ethine, you need to consider this. When we treat ethine with red hot Fe tube, right? Red hot Fe tube, then benzene will form. Now, the general formula is CnH2n minus. This is a quick summary. Okay, so this is a quick summary what we study in case of alkyne. कि हमने alkyne में क्या क्या पढ़ा. So the general formula for alkyne is CnH2n minus 2. Suffix we use is "ine". Isomerism, so they show just structural isomerism. In preparation, we study only two methods. One is from calcium carbide, and the next is from vicinal dihalide. We also studied that how the calcium carbide is produced in the industries, right. The second method is vicinal dihalide. Okay, now in physical property, we study important things like they are colorless, odorless, they are insoluble in water, starting 2 to 4 members are gaseous, then liquid, and rest are solid in nature. In chemical properties, the most important point is acidic nature of alkyne. That alkyne are very good acidic in nature. Why? Due to presence of alpha hydrogen. So due to the presence of this alpha hydrogen, they behave as a very good acidic in nature. So this is about the ethine. Now, addition of H2. So when we add H2 in alkyne, then formation of alkene followed by alkene takes place. Similarly, when we treat alkyne with halogen, then dihaloalkane will be formed, right? Next, in chemical properties, we study about the addition of HX. That what happened when we add hydrogen halide. So in this, we follow the Markovnikov's rule. And in H2 addition as well, we follow Markovnikov's rule. So these are the chemical property that we study. Now, the next chemical property that we already covered is polymerization. So in polymerization, we study the two type of polymerization. The first one is a linear and the second one is a cyclic polymerization. So in linear polymerization, the n number of ethine, right? Okay, so in linear polymerization, when the n number of ethine is treated, right? So when the n number of ethine is treated, and or we say when the polymerization of n number of n monomers of ethine, then polyethylene will produce. In cyclic polymerization, this is very, very important, in which we study when we took 3 mole of ethyne, and when we treat with the red hot iron at 873 Kelvin, ethyne, 3 mole of ethyne, red hot iron tube, 873 Kelvin, then formation of benzene will took place. Okay? So this is all about the alkyne, their method of preparation, their physical properties, and their chemical properties. Anyone having any kind of doubt in alkyne, you can ask. फटाफट पूछो. 2 minutes you all have. किसी को कोई भी डाउट हो, कुछ भी नहीं समझ आया हो, कोई भी टॉपिक अभी अभी जो हमने किया है, सो यू कैन आस्क. उसके बाद हम फिर थोड़ा सा इंट्रोडक्शन पार्ट वी आर गोइंग टू स्टार्ट. ठीक है, तो जल्दी से बता दो एक बार. यस. ऑल क्लियर. ओके. एनीवन एल्स. चलो भाई. Now, let's see some aromatic hydrocarbons. Okay, so we have aromatic hydrocarbon next, and this is the last topic of this chapter. First, we study about alkane, then alkene. After today, we are already completed alkyne. So the next topic is aromatic hydrocarbon. What is this aromatic hydrocarbon basically? So what are the learning objective? That is the introduction of aromatic hydrocarbon, structure of benzene, resonance and stability of benzene, preparation of benzene, properties of benzene. So this is the thing we are going to study under this aromatic hydrocarbon. Okay, now let's start with the introduction of aromatic hydrocarbon. So they are also known as arenes. So aromatic hydrocarbons are also known as arenes. And most of these arene possess pleasant odor, right? So first thing is they known as arenes. And most of the arenes possess pleasant odor. ये pleasant smell odor होता है इनका. That's why they are called aromatic compound. Aromatic word comes from the word aroma. Aroma means something which is pleasant smelling, right? So their smell is very very pleasant. So we can say that most of the arene possess pleasant odor, that is or aroma. ओके. सो अगर कोई पूछता है एरोमेटिक कंपाउंड क्यों बोला गया इनको, तो याद रखना इनका एरोमेटिक कंपाउंड का नाम एरोमा वर्ड से आया है. एरोमा वर्ड का मतलब ये होता है जिनकी बहुत अच्छी फ्रेग्रेंस होती है. ओके. चलो. Most of the arene were found to contain highly unsaturated benzene ring. Okay. So most of the arene were found to contain highly unsaturated benzene ring. Now, aromatic compounds are classified as benzenoids and non-benzenoids. This thing we already studied, right? Benzenoid and non-benzenoid. So aromatic, we can classify aromatic compound as benzenoids and non-benzenoids. Now let's see with an example. So this is benzene. This is in a toluene. This is called toluene. Okay. So this is benzene. This is toluene. This is called biphenyl. तो benzene हो गया, toluene हो गया, and biphenyl हो गया. Remember this thing, right? So benzene, toluene, and biphenyl. Similarly, if we talk about the isomers of aromatic hydrocarbon, so all six hydrogen atom in benzene are equivalent, right? All they are in equivalent. So one type of mono-substituted product for di-substituted compound, three position isomer are possible. तो याद रखना, because all six hydrogen atom in benzene are equivalent, है ना? So one type of mono-substituted product ही बन पाएगा. And for the di-substituted compounds, three positions isomer are possible that are called ortho, meta, and para. Right. So, for example, this is in a case of di-substituted compound. So, di-substituted compound may either we have 1,2-dimethyl benzene, also known as orthoxylene. Now, अगर ये मेटा पे लगा होता तो that is called metaxylene. और अगर पैरा पे लगा होता तो दैट इज कॉल्ड पैराजाइलिन. ओके, सो दिस इज अबाउट ऑर्थोजाइलिन, मेटाजाइलिन एंड पैराजाइलिन. डन. Now, so the structure of benzene. So let's talk about some point about the structure of benzene. ठीक है. So it was discovered by the Michael Faraday in 1825 that the molecular formula of benzene, that is C6 and H6, it contain high degree of unsaturation but very stable. ठीक है. So these are some points about the structure of benzene. So first of all, it was discovered by the Michael Faraday in 1825. Molecular formula of benzene is C6H6, as we all know. High degree of unsaturation but quite stable. And benzene form a triozonide on reaction with the ozone. So when we treat with ozone, they form triozonide. That it indicates the presence of three double bond. तो ये बताता है इसके अंदर पक्का थ्री डबल बॉन्ड्स होंगे. नाउ, फाउंड टू प्रोड्यूस सिंगल मोनो सब्स्टिट्यूटेड डेरिवेटिव, indicates all carbon atoms and all hydrogen atom are identical in nature. Now, so in next class, basically we are going to see more detail about the structure of benzene. Here just we see the some basic structures. Like if you consider benzene, सबको पता है ना benzene का ये structure होता है. We have a pi bond, alternate pi bonds होते हैं. Pi bond, single bond, pi bond, single bond, pi bond. Right. So alternate होते हैं. So calculate structure indicate the possibility of two isomeric, that is called 1,2 disubstituted benzene. So Kekule proposed the structure of benzene as well, right? So उन्होंने क्या बताया कि भाई इनकी टू आइसोमेरिक, दैट इज 1,2 डाइब्रोमो सब्स्टिट्यूट बेंजीन का बन सकता है. हाउएवर बेंजीन वाज फाउंड टू फॉर्म ओनली वन ऑर्थो डाई सब्स्टिट्यूटेड प्रोडक्ट, ऑसिलेटिंग नेचर ऑफ डबल बॉन्ड, जो एक से दूसरी जगह पे डीलोकलाइज करते रहते हैं, राइट. नाउ केकुले स्ट्रक्चर ऑफ बेंजीन फेल टू एक्सप्लेन द unusual stability and preferences to substitution reaction than addition reaction, which could later on explained by the resonance. So we are going to see the resonance structure and all this thing in detail in next class, right? So today we are हम यहीं पे stop करेंगे इसी पे. So अगर किसी भी बच्चे को कुछ भी डाउट हो तो एक बार जल्दी से पूछ लो फटाफट बेटा. अदरवाइज हम लोग फिर इसको एंड करेंगे. So anyone having any kind of doubt? I'm just launching a quick poll here. Everyone need to fill this poll, right? सभी लोग fill करो. Everyone fill करो poll को.